name's Lewis Smith. I have a question for Dr. Calabrese. I think that why don't you comment on the absence of mechanistic data when you produce Hormesis-based dose response curves? Because if you just take one compound like tamoxifen, which you probably looked at because at low doses it will actually stimulate tumor growth, and at high doses it will actually prevent tumor growth in the breast. At low doses it will do nothing to the metrium. High doses it will alter the endometrial epithelium. This compound actually was developed. It was the most widely used anti-cancer drug for breast cancer up until about 10 years ago. It was developed as a contraceptive. It failed as a contraceptive, but actually it got a license for causing ovulation in women. It was a replacement for Clomid, which is only a chlorine away. The point I'm really making is that even with one compound in one organism, female, you can get 3 different dose response curves. So when you generalize, my concern and question is, when you generalize Hormesis dose response curves, it is interesting, but not always very informative about what is going on, because it can be different cells that are taking part in the second part of the Hormesis dose response curve. The first group of cells may well be inhibited or stimulated, but it can be a second group of cells that are actually responding to the higher doses which are present in the organism.
I appreciate your comments. I agree with what you're saying, and all this takes considerable experience and insight on the experimental level, and all kinds of possible explanations for biphasic dose responses exist and really have been reported. So I fully agree with the general thrust of what you're saying.
So yes, I think that's a central theme to what we've been talking about today. As Joseph Maka mentioned in his comments, he talked about the adverse outcome pathway, the AOP, and that's a paradigm shift here in the field of toxicology, but it very much aligns with the field of nutrition and understanding those pathways to perturbation, as understanding of where you get to too much is too much. And what I think that when we think about this, can bring the questions on what's adverse. So you can have differential effects, and you may see this effect first, and while you look at the whole organism, you can end up looking at an effect that is hormetic, but then try to put that on the AOP pathway and say that that change is related to the endpoint. So, yeah, very good question, and very relevant to the questions we've had. Go ahead, John.
Yeah, I have a question for Ed. Has any of this work been applied to mycotoxins? Mycotoxins, unavoidable, contaminant, controllable. But if you look at the curves you've generated for many of these other things, it would seem to me that the levels that should be set would be that crossover point with the control, as opposed to the more linear approach that I think has been done so far.
In terms of what hormesis has actually been applied to in a regulatory sense is pretty much limited. It hasn't been applied by regulatory agencies. It's been discussed in great detail. EPA's had workshops on it internally and so forth. I think they're trying to figure out how to deal with it. I think that where hormesis actually has been applied is actually throughout the pharmaceutical world. And that is, if you take a look at some of the examples that I mentioned, but many other ones, essentially the many examples with the anti-seizure, anxiolytic, osteoporotic, and many drug classes, these studies are really coming out of preclinical data, and then the preclinical data is ultimately selected for clinical trials. And they're basing those doses on the preclinical data as the initial run through. So in effect, many of the drugs that are useful today that we might be taking are actually based upon hormetic dose responses that have been obtained in preclinical data. So actually, the world of what I'll call pharmacology and commercial pharmacology is based very strongly upon hormetic dose responses in the preclinical literature. The application to the environmental world is far behind that.
Great. Joe?
You partially answered the, whoops, is that too loud? Partially answered the question I have, Ed, about the sort of policy implications of hormesis, and put aside the pharmaceutical world, because I think that's a different entity. Maybe you think of it as another example of hormesis, but what we're dealing with in the rest of the chemical world are things that cause adverse effects at high doses, and I think you're saying that the current methods of risk analysis put exposures well below any range which is potentially beneficial. I'm not sure why you, by the way, want to avoid the words excess risk and benefit at the low dose region. But you're saying we ignore that region where there might be what you call stimulation, or the opposite of what's occurring at the high dose. And so I think you would say we ought to be focusing on that region of decreased risk, I'll put it that way, and finding some level there at which we think we're going to maximize the benefit to people. Is that how you would sort of set this up as a sort of risk model within the chemical world? And let me add one more question, and then you can answer both. How would you have you thought about the issue of nutritional deficiency as a stress, and what hormesis would look like in that case, the case of nutritional deficiency?
I'll try to go after the first one first, and that is, from a regulatory point of view, the most significant cost situation is the regulation and cleanup and control of exposure to carcinogens. And this has been dominated by a linear dose-response relationship, essentially trying to deal with risks that might approach 1 in a million, that sort of thing, depending upon the agency, the compound, and the circumstance. Recently, I published a series of papers to try to take a look at how you can reconcile what's going on hormetically with the linear dose-response relationship. And what our work has come forth in saying, and that is that if you take a look at the nadir, or the nadir of the dose-response curve, and you try to essentially see what that relates to with regards to risk coming from a linear dose-response relationship, the optimal dose for the predicted reduction in tumors is actually at the is actually at 10 to the minus 4 with respect to the LNT. And so essentially what I would recommend, and that is that you could actually optimize a public health response by increasing the acceptable exposure from 10 to the minus 6 to 10 to the minus 4, incorporate a kind of what I'd say model uncertainty concept that actually would use LNT as an upper bound and hormesis as a lower bound. And essentially, when you take a look at the predicted population-based response, it's really optimized at 10 to the minus 4. And by optimize, it really, in theory, would have, is what the regulatory agency would like. Going in either direction actually reduces the overall population benefit. So in effect, the hormetic dose response is, I would claim that you don't have to actually have model uncertainty. It's better than the LNT, but I'll just accept that both models are imperfect, and that they define a range of response, and that hormesis has as much legitimacy to that discussion as LNT. and the optimized use of both of them brings the risk to 10 to the minus 4 on LNT. So it essentially would have a huge impact on the regulatory community for standard setting cleanup, worker protection, and so forth. And so that answers, I think, part of Joe's question. In terms of nutritional deficiencies and how this would work, the closest I've come to try to address that situation is probably about 10 years ago, I wrote an article for the Annual Review of Public Health on hormesis. And one of the members of the board of directors essentially decided to write an article in the same issue criticizing my paper. I've never seen that actually done before in an annual review. Usually when you write an annual review, you're supposed to know something. This person, but it was a fair question. He said, you talk about hormesis, but the big question, one of the big questions is, how does hormesis address those at high risk? It's a bit what Joe's kind of using a specific example of. And so I agreed with his criticism and didn't really mind the challenge. We went into our database and we found actually lots of examples where you could evaluate inter-individual variability with respect to hormetic dose responses. And what we found was that those who are much more compromised than those who would be much more resistant would still show a hormetic dose response, except they would show it at a lower dose, be pushed to the left on the dose response spectrum, but the quantitative features would be the same. We did find some examples where certain developmental stages or other conditions, people or the models may have lost or did not have a hormetic response due to some particular reason. It could, as I said, be developmental, or you could lose it in age, something along those lines. But at least looking at high-risk groups, they would still have the same quantitative features of that dose response. And in our database, there were many, many examples where the differential susceptibility was evident with hormesis.
Oh, great. So we have time for one last really quick question.
Yes, Jenny Jim from ILSI, Taiwan. Taiwan government is trying to put a guideline on processing aid. And during drafting the guideline, one thing's on the quality standard. So there are quite a few processing aid covered in Codex inventory, close to 400 to 500. But when we look into food chemical codex, there are not just a few specific monograph covering on the quality standard. Can you comment on that?
Yeah, I'll have to beg the fact that I couldn't hear you. My hearing is not very good.
So maybe we could take that offline and you guys can connect directly. Yeah. That would be great. So, so wonderful. Thanks, everybody. Excuse me. Thanks for hanging in for a long session. We're going to wrap it up now. I'm going to turn it over to Chris to make some her concluding remarks, and then I'll come back.
Thank you very much. The assignment was reflect on what you've heard and what you've learned. And as I've thought about it, I did predict that this would be a challenging set of conversations, but what I am amazed at is the level of consensus that came through. I honestly wasn't expecting that, and I'm totally impressed with what I saw were a lot of commonalities in the points that people were making. We did know that the original Brightline model wouldn't work perfectly as it moved along that continuum into food additives, nutrients, and other substances. I think what we didn't know, even as we were embracing this idea of the U-shaped curve, was really how much adaptation was needed. We knew it would be adapted, had to be, but I don't think we understood how much was really involved. And I liked Joe's comment, Joe Roderick's comment, that maybe one of the things that's the starting point here is changing this sort of set of assumptions that you go into when you consider these kinds of risk assessments. You called it science policy. I would call it a set of starting assumptions for the way you set up a risk assessment. And I think that links a little bit with Johanna's comment about common language. Common language is part of a common understanding, and I think we've been lacking that in some of the things we've done. heard really clearly that there's a need for an underpinning of mechanistic data. Obviously, we need data left, right, and sideways, but mechanistic data to me seemed a lot more possible than a lot of the other kinds of data that we need, and I think that would be a helpful addition. And at the other end, we really need better ways of approaching how we take care of epidemiological data, because we are going to have epidemiological data. So we've been kind of waltzing around epi data saying, well, the top of the pyramid is clinical trials, we really need clinical trials, so we've got this epi, we'll work with it. We've got to focus on epi being it. And again, Joe Roderick's comment about how we integrate it is critical. The use of risk assessment, the word came up, probabilistic risk assessment. I like that because it does sort of help us understand that the bright line is something over here, and now we're thinking more about the probabilistic. I think that is a way to think about it, but I think it's extremely complicated, and you do need a set of principles. If you speak about risk assessment, and you speak about probably not having data, you have to go back, I think, to that original 1980s thought that risk assessment will always be about not having enough data. It's not as if in the case of the rats in the cage with the red dye number 2, you had enough data. The thought was you always wouldn't. And so a really, really big part of risk assessment has been documentation and transparency. And that links really clearly to something, again, Joe Roderick said, which is we've got to do a better job of describing what's uncertain about what we're doing. Because I think a lot of the problems and a lot of the misunderstanding is you put it out there and it's a fait accompli. If you say we've got some uncertainties here, it calms everything down. So I do think describing uncertainty, being very transparent, because this is, in the end, scientific judgment. It's not a little recipe that you crank and out comes the answer. There will be scientific judgment. I'm going to end by saying that we have to do the work. For those of you that know anything about that WHO book, it did start things going because they had to put down on paper what to do. We've had a number of meetings now where we've waltzed around what the questions are. And Johanna was the one who sounded the theme saying, we've got to get organized. I think first we need to know what questions we have to ask ourselves. We need workshops and conferences that begin to get at it. And then somebody's got to start to pull together these big reports, these guidance documents that help us. So that's my theme.
Thanks, Chris. I'm not going to take too long on this and just say that I think that we've demonstrated here today in this session that there's a lot of work to be done in the future. And hopefully you've taken away the fact that there's a multifactorial endpoint as well. So we have health and nutrition outcomes that are of importance as understanding what an adverse effect is and what an effect is not adverse. And then we also have the commercial operational aspect of adding additional constraints and or understanding what the commercial availability and risks associated with differential ingredients and food constituents are. So it all folds up into the total package of what we do as an industry, and that is to provide the world with ample and nutritious food. So with that, I'll bring it to a close. And again, thanks everybody for hanging in. And I think it was a great session. I look forward to any discussions afterwards. So have a great lunch and enjoy the rest of the day. Thank you.